For decades, advocates of plasma cosmology and the electric universe argued that electricity and plasma play a far greater role in the universe than conventional models allow. Rather than seeking to replace modern astronomy, they proposed broadening its conceptual framework. They spoke of cosmic electrical activity, planetary catastrophes, plasma phenomena preserved in ancient myth, and even the possibility that space itself possesses structure and energy. At the time, many of these ideas were dismissed outright. Today, however, the landscape is beginning to change. Plasma filaments fill astronomical journals. Catastrophism is back on the menu. Ancient civilizations and forgotten chapters of human history attract enormous audiences. Researchers openly debate the vacuum, the energy of empty space, and unconventional forms of propulsion. To be clear, this does not mean mainstream science has embraced the electric universe. It has not. But the conversation has changed. Questions once considered settled are being reopened. Ideas once confined to the margins are steadily moving toward the center of scientific discussion. This is not a story about victory, it is a story about persistence. Many of the questions now attracting renewed attention were first raised decades ago by researchers such as Christian Birkeland, Hannes Alfvén, Ralph Jürgens, and Immanuel Velikovsky. Before Anthony Peratt, David Talbot, Wallace Thornhill, and others revived and expanded the discussion. Whether they ultimately prove right or wrong on every issue is beside the point. They kept important questions alive when few others were willing to ask them. Perhaps the most interesting development is not that these ideas exist, but that so many of them are being reconsidered. Plasma, catastrophism, ancient testimony, the structure of space, unconventional energy, and questions about consciousness and humanity's forgotten past. For years, these subjects survived on the fringes of scientific debate. Now they are returning, and science advances not by silencing questions, but by asking them. Quote, I would rather have questions that can't be answered than answers that can't be questioned. End quote. Richard Feynman. One of the most striking developments in modern astronomy is the growing prominence of plasma. This should come as no surprise. At least 99% of the observable universe is plasma. Stars are plasma, nebulae are plasma, the solar wind is plasma, vast regions of interstellar and intergalactic space are plasma. Recent observations have revealed immense filamentary structures stretching across the cosmos, renewing interest in the role plasma may play in shaping the large-scale structure of the universe. The question was never whether plasma exists. The question was always how important it is. Advocates of plasma cosmology have long pointed to the remarkable similarities between structures observed in space and those produced in laboratory plasma experiments. Filaments, cells, knots, and twisting currents appear across an extraordinary range of scales. Whether these similarities reflect common electrical processes operating throughout the cosmos remains open to debate, but the visual correspondence is becoming increasingly difficult to ignore. This is where the real disagreement begins. Conventional cosmology regards gravity as the primary architect of cosmic structure. Plasma cosmology argues that electromagnetism is not merely a secondary influence, but a fundamental force shaping the universe across every scale. The question is no longer whether plasma matters, it is how much it matters. Are we witnessing the beginning of a paradigm shift? One of the curiosities of scientific history is that ideas often become respectable only after the people who champion them have been ignored, ridiculed, or forgotten. Long before plasma filaments became commonplace in astronomical journals, Norwegian physicist Christian Birkeland proposed that electric currents flowed through space. Through pioneering laboratory experiments, he demonstrated how charged particles interact with magnetic fields, helping to lay the foundations of modern space plasma physics. Many of his ideas were dismissed. Today, Birkeland currents are an accepted part of space science. A generation later came Hannes Alfvén, Nobel laureate and pioneer of plasma physics. Alfvén repeatedly warned that elegant mathematics should never replace experimental reality. His insistence that plasma be understood through observation and laboratory experiments remains as relevant today as ever. Outside mainstream astronomy, Immanuel Velikovsky asked a different set of questions. He argued that ancient myths and traditions preserved memories of real catastrophes. Although many of his specific conclusions remain controversial, his broader challenge, that ancient testimony may preserve genuine historical memory, has proved remarkably enduring. Perhaps his greatest heresy was not catastrophism itself, but the suggestion that electromagnetism played a far greater role in nature than Newtonian physics generally allowed. Velikovsky believed that theories must adapt to evidence, not the other way around. Quote, if occasionally historical evidence does not square with formulated laws, it should be remembered that a law is but a deduction from experience and experiment, and therefore laws must conform with historical facts, not facts with laws. End quote. Immanuel Velikovsky. Later, David Talbot and Anthony Peratt forged an unexpected bridge between mythology and plasma physics. Peratt's plasma research revealed forms strikingly similar to symbols found in petroglyphs around the world, while Talbot documented recurring celestial imagery across ancient cultures. Together, they posed a fascinating question. Why do societies separated by vast distances and centuries repeatedly depict the same unusual forms in the sky? More recently, Wallace Thornhill helped bring these ideas to a wider audience, challenging conventional assumptions about cosmology and the role of electricity in nature. What unites these figures is not that they agreed on every detail. They did not. What unites them is their willingness to ask questions others preferred to avoid. One of the most intriguing developments of recent decades has been the growing willingness to revisit ancient traditions with fresh eyes. For much of the 20th century, myths and legends were treated largely as products of imagination and superstition. Today, an increasing number of researchers recognize that they may also preserve fragments of genuine historical memory. Around the world, ancient cultures preserved remarkably similar accounts of floods, celestial upheaval, cosmic battles, and periods of disorder. For generations, such stories were dismissed as folklore, yet as evidence for abrupt climatic and geological change continues to accumulate, a simple question arises. What if our ancestors were describing real events? Ancient peoples lacked the language of modern science. They spoke instead of gods, dragons, thunderbolts, and celestial weapons. The language was different. The observations may have been the same. Science provides physical evidence. Myth preserves human testimony. Together, they may offer a richer picture of the past than either can provide alone. Perhaps one of the most intriguing developments in recent decades has been the unexpected meeting of plasma physics and archaeology. The central figure in this story is plasma physicist Anthony Peratt. While studying high-energy plasma instabilities, Peratt observed a series of distinctive forms that appeared repeatedly in laboratory experiments and computer simulations. Then something remarkable happened. When David Talbot showed him images of ancient petroglyphs collected from around the globe, Peratt immediately recognized many of the shapes. Some closely resembled plasma configurations he had previously encountered in a classified research environment.
My first introduction to petroglyphs was by David Talbot. I went to a meeting of his by accident and learned something about what they were doing, and then he showed me some pictures, and I looked at the pictures, and I said, where did you get these pictures? Because I had never seen them outside of an unclassified environment, to tell you the truth. And they're on rocks. They're on rocks. Where are these rocks stored? What vault? It's got these rocks. And I was kind of, what am I going to do now? And he said, oh no, they're all over. They're petroglyphs. They're all over the place. And I was stunned. having worked in what's called high energy density plasmas, high energy density in nuclear physics, I was stunned that these pictures, apparently thousands of years old, preceded what we'd only been recording for about 2 years with our new facilities. It cost a lot of money.
The significance of Peratt's work lies not merely in the visual similarities, but in their extraordinary geographical distribution. Comparable symbols have been documented on multiple continents among cultures with no obvious contact. Ancient people, separated by vast distances and thousands of years, repeatedly depicted radiant columns, hourglass shapes, ladders, stick figures, and other distinctive motifs. Why? Peratt proposed that ancient observers may have witnessed extraordinary plasma phenomena in the sky and recorded what they saw in stone. The idea remains controversial, yet it provides a compelling explanation for the remarkable consistency of these symbols across cultures. Could this be coincidence, psychology, collective memory, or ancient observation? The debate continues. What is clear is that a subject once dismissed out of hand is now part of a serious scientific discussion. If some of these symbols really do record unusual celestial events, they lead naturally to one of humanity's oldest and most widespread traditions, the Thunderbolts of the gods. If there is one symbol that appears with extraordinary consistency throughout the ancient world, it is the thunderbolt. From Greece to Mesopotamia, from India to Scandinavia, gods were repeatedly associated with luminous weapons in the sky. Zeus wielded his thunderbolt. Indra carried the Vajra. Ninurta brandished a celestial weapon. Thor hurled weapons of power from the heavens. The cultures changed, the names changed. The imagery remained remarkably similar. Most scholars regard these thunderbolts as symbolic representations of divine power. Laboratory plasma experiments have repeatedly produced electrical discharge formations that bear a striking resemblance to ancient thunderbolt imagery. In many cases, the similarities are difficult to ignore. Viewed alongside myths describing celestial battles, blazing skies, radiant pillars, dragons, and terrifying displays in the heavens, the similarities become harder to dismiss. The conventional view is that these stories are symbolic rather than historical. The electric universe offers another possibility. Ancient people may have witnessed extraordinary electrical phenomena in the sky and described them using the language available to them: gods, dragons, celestial weapons, and cosmic battles. Whether one accepts that interpretation or not, the remarkable consistency of the symbolism demands explanation. The thunderbolt is not a local tradition, it is a global one. And if these myths preserve even a fragment of historical memory, the skies of the ancient world may have been far more dramatic than anything we witness today. Few ideas generated more hostility in 20th century physics than the ether. For generations, students were taught that the concept had been discarded and that space was essentially empty, yet modern physics now paints a very different picture. Today, physicists speak of quantum fields, vacuum fluctuations, zero-point energy, dark energy, space-time, and the energy of empty space. The terminology has changed, but the underlying question remains remarkably familiar. Can space truly be empty? The classical ether may not survive in its original form, but the idea that space possesses structure and energy has quietly returned to scientific discussion. Some calculations even suggest that so-called empty space contains an astonishing amount of energy. The challenge is no longer whether that energy exists, but understanding its nature and whether it can be harnessed. These questions have also spread beyond conventional physics. Discussions of advanced propulsion, unconventional energy, and the UFO-UAP phenomenon frequently return to the same possibility, that space itself may be an active medium and not an inert void. For advocates of plasma cosmology and the electric universe, that possibility has long been central to their view of the universe. Whether modern physics ultimately returns to something resembling an ether remains to be seen. For now, one thing seems ever clearer. The more we learn about empty space, the less empty it appears. Given that plasma is reshaping our understanding of the cosmos, might it also reshape our understanding of energy? For decades, most energy researchers focused on chemical fuels, nuclear reactions, and renewable technologies. Yet plasma continues to reveal behavior that is often unexpected, even under carefully controlled laboratory conditions. The Sapphire project demonstrated that many complex plasma phenomena can be reproduced experimentally, while its successor, Orion, has expanded this work towards practical applications. Current research includes elemental transmutation, the remediation of radioactive waste, advanced materials processing, and the development of new forms of energy technology. Although much progress has been made, there is still a long way to go. What is clear, however, is that these projects reinforce the lessons Hannes Alfvén championed throughout his career. Nature often reveals her deepest secrets through careful experimentation, rather than theory alone. The electric universe remains controversial because it challenges conventional assumptions about how the universe works. Many of its central claims continue to be debated. Yet one thing is becoming increasingly clear. Subjects discussed for decades by advocates of plasma cosmology and the electric universe are now receiving more attention than any point in recent memory. Plasma is no longer a niche topic. Catastrophism has returned to mainstream discussion. Ancient testimony is being reconsidered. The nature of the vacuum remains an open question, and interest in unconventional energy and propulsion continues to grow. For decades, a small number of researchers kept these conversations alive. They looked again at subjects many believed had already been settled. These conversations continue. The history of science reminds us that today's heresy can become tomorrow's orthodoxy. Scientific progress depends not only on new discoveries, but on the willingness to re-examine old assumptions. The electric universe has long argued that electricity, plasma, and electromagnetic processes play a far greater role in shaping the cosmos than conventional models have allowed. The extent of that role remains the subject of active debate, but the growing recognition of plasma structures throughout the universe suggests that those questions are not going away anytime soon. Science advances not by silencing questions, but by asking them.